Welcome to the probably not so mini lecture on Chapter 11, Aggregate Demand 1, Building the ISLM Model. I regret to inform you that this is the most difficult chapter in the book. At least it seems that way to me, because I remember learning this stuff, and it was a little painful. Anyway, I'll try to relieve you of some of that pain. In Chapter 11, we will build the ISLM model. You'll see where it comes from. Then in Chapter 12, we will use this model to make predictions and to predict the result of various policy choices. Now, let's see here. What is the ISLM model? Paul Krugman, who is a supporter of Keynesian economics. All right, let me back up. The ISLM model was created by, indirectly in some ways, by John Maynard Keynes. Here we go. This is Keynes. This is his magnum opus, The General Theory of Employment, Interest, and Money. You got to have a little hubris to write a book with a title like that. Like writing a book titled How Everything in the Universe Works. It's a lot. Historical background. 1929. Stock market crashes. That is the beginning of the Great Depression. In the very early 1930s, boy, there was a lot of pain in the country. And the prevailing school of thought, economic school of thought at the time, said, this is a normal part of the business cycle. It will fix itself as long as you don't mess it up. Just leave the economy alone. The ship will right itself. Whether that was true or not, politically is irrelevant. There are times when doing nothing just won't fly. People were demanding that politicians do something. So what were they going to do? Keynes's theories said that you can fix this by taking these various actions. Again, whether it's right or wrong, politicians grabbed onto that theory because it gave them a justification for action, which was a political necessity. Any politician at the time who said, let's just do nothing, it'll fix itself, would have been voted out of office. So FDR put in place these policies, and this is what became known as Keynesian, the basis of Keynesian economics, generally associated with the political left nowadays. Okay. The ISLM model, it was a slightly later edition way of explaining Keynes's theories. His book, strangely enough, only contained one diagram in the whole book. So a lot of these diagrams were created by other economists after that to sort of explain what Keynes had written in words. What does it all mean? What is the purpose of this ISLM model? Paul Krugman, Nobel Prize winning economist and a fan of Keynesian economic theory, explained it pretty well. My favorite of these approaches is to think of ISLM as a way to reconcile two seemingly incompatible views about what determines interest rates. One view says the interest rate's determined by the supply and demand for savings, the loanable funds approach. The other says the interest rate's determined by the trade-off between bonds, which pay interest, and cash, which does not. But you can use cash to buy things as a liquidity value. This is the liquidity preference approach. In this, the first view, that the interest rate is determined by the supply and demand for savings, that's the IS part, investment savings. The perspective that it's determined by the trade-off between bonds, which pay interest, and money, which does not. Cash in your pocket doesn't earn interest, but has a liquidity value. That is the LM part, liquidity money. Okay. Now, let's start with this. Assuming I can make this work. This is the ISLM graph. It shows an equilibrium between the interest rate and output, GDP. This is the IS curve. This is the LM curve. And this is the equilibrium, interest rate, and output. Looks pretty simple, doesn't it? It's not. All right, where does this come from? These two curves, well, that doesn't work. Okay. The IS curve shows all of the equilibrium points for sometimes called the goods market, or the market for loanable funds. It's for investment and savings. Let's see if I can make this bigger. It shows the relationship between the interest rate and output. From this perspective, if the interest rate is high, nobody's going to want to borrow money and invest it. So that'll tend to make the economy smaller. But also, if the interest rate is high, everybody's going to want to save money, put it in the bank, get that high interest rate, which means you can't save and invest. You can't save and consume at the same time. So if you're saving a lot, you're consuming less. That also tends to reduce the size of the economy. So high interest rate, low GDP, and the converse. Low interest rate, everybody wants to invest, which means investment will be high, and nobody wants to save, so consumption will be high. All right, that's the IS curve. The LM curve also shows the relationship between interest rate and GDP, but from a different perspective, from the liquidity money perspective. People want to hold cash because cash can be used to buy things. It's liquid. But people also don't want to hold cash because cash doesn't earn any interest. If you stick it in the bank, you earn interest. So there are these two competing influences. If the interest rate from this perspective is very high, then, well, actually, let's go the other way. If the economy is really, really big, there's lots of stuff to buy. You're going to need to hold a lot of cash to buy that stuff. If you're holding a lot of cash, that means you're not saving much. You're not putting much in the bank. Well, if there's not a lot of savings available for investment, the price of investment is going to go up. Big economy, high interest rate. On the other hand, if the economy is tiny, there's not much to buy. You're not going to hold a lot of cash because there's not a lot to buy with it. You're going to put your money in the bank, get some interest. Well, if everybody's putting their money in the bank, there's all sorts of money available for investment, which means the price of investment is going to be low. If everybody puts their money in the bank, the interest rate will drop because banks will be able to get all the money they need to lend without paying much. So low GDP and low interest rate. Well, these two are opposite. So where do these curves come from? All right, the IS curve comes from here. I'll get into the details of all this shortly. That's the IS curve. It shows a relationship between the interest rate and output. It's downward sloping. It comes from this curve. This graph is called the Keynesian cross. It shows the relationship, and this will not make any sense to you at first, but I'll explain it. Shows the relationship between actual spending and planned spending. In this model, it's called planned expenditures. And it makes predictions. If the interest rate is this, you're at this equilibrium. If it's that, you're at that equilibrium. So it ends up equating output with interest rates. If you plot that, you get the IS curve. The LM curve comes from this graph. It shows supply and demand for money. Interest rate is the price of money. The money supply divided by the price level, that's real money balances. It's sort of like the quantity of money in terms of how much you can buy. It makes predictions, which then you use to drive the LM curve. All right. Now, getting to understanding those things. All right. The IS curve. It shows the relationship. Actually, you know what? I'm going to put in an extra slide just to draw something else for you. Okay. Here. The Keynesian cross. Regardless of, boy, my handwriting's bad. Well, I am a doctor. I need more coffee, obviously. The Keynesian cross, forget about what the curves look like on it. The axes show planned expenditure. Let me do that a little. It's a graph of planned expenditure versus output. The IS curve is a graph of interest rate versus output. So it is output here that is the output on that graph. Plotting this against the interest rate. Now for the LM curve, we have the supply and demand for real money balances. So this is the interest rate versus demand for real money balances. Then the LM curve is the interest rate versus output. So here, you are taking the interest rate predictions and constructing the LM curve. All right. Now, for the full ISLM diagram, this 1 point, this size GDP at this interest rate is the only combination where both markets are in equilibrium. I never found that particularly difficult to understand. Really, it's the Keynesian cross that gives people more trouble, so I'll spend a good bit of time on that. Okay. Here, planned expenditure. Actually, let me go to the other one first. The Keynesian cross is plotted with output versus planned expenditure. Sometimes this is called actual spending versus planned spending. Well, what? That was never at all intuitive to me. Here's the way I think of it. It's 95% technically correct, but I think it's much easier to understand. This is a graph of the short run, but think of it as a graph of the long run. Think of this as long run, let's see. Long run spending, short run spending. Kind of. In the long run, you know what? I'm going to take that back and try this. In the long run, everything that you consume must be produced, and everything that is produced will be consumed one way or the other. So in the long run, if you think of this just as output, well, income too, and this as, in a way, consumption, spending. Well, in the long run, the two have to be equal. If income is that, in the long run, spending's going to be the same. You can spend more than your income temporarily, or less than your income temporarily, but in the long run, they have to be equal. But in the short run, they do not have to be equal. If your income is $100 today, you don't have to spend $100 today. You can spend 80 and take 20 and spend that later or do something else with it. If your income's 100 today, you can spend 120 today by consuming what you did not consume earlier. this part of the graph says that if your output if your income is, let's say, 0, let's plot some points. Your income is 0 today. Is your spending going to be 0 today? No, it's not. You're going to spend something today. If it's Sunday, you're not working, you're not earning money, you're still going to eat. So you might be at that point there. Now, let's say that your income increases on this one day by $100. If your income goes up by $100, your spending is also going to go up, but not by $100, because we have a marginal propensity to consume that is less than 1. If I give you $100, you're going to spend some of it. You're also going to save some of it. What's that fraction? That fraction is the MPC. Here, it doesn't matter what the number is, but the point is that it's less than a 45-degree angle. If we were here, income goes up by 1 unit, spending goes up by 1 unit. The slope of the curve is 1. That would be an MPC of 1. But because the MPC is less than 1, what is this? The slope of that curve, 0.7. If your income goes up by 1 unit, your spending is going to go up by something smaller than that. Income goes up by $100, spending might go up by 70. That's why the slope of this is less than 45 degrees. And any moment you do not have income, you don't immediately stop eating, which is why the intercept is not 0. This planned expenditure, we say, is composed of personal consumption, plus investment, that's a form of consumption, plus government, which is also a form of consumption broadly. So planned expenditure is C plus I plus G. Think of that as what's being spent today. In the long run, though, this has to be true. Well, if you put them together, you get the Keynesian cross. Think of it as the long term, expenditure has to equal output. In the short term, not necessarily true. It's going to follow this curve, where if income goes up a certain amount, spending will go up less than that amount at the rate of the marginal propensity to consume. Now, let's assume that you are here. Income is 100. Well, if you spend 80 here, what happens to the other 20? Well, if $100 comes in and you only spend 80, 20, it kind of like gets put on a shelf. Think of this in terms of items, of product instead of money. If 100 widgets are built today, but only 80 widgets are bought by people and used, where do the other 20 widgets go? They go into the warehouse, into inventory, so that they could be sold later, perhaps. That means that inventory, if we are to the right of this point, then consumption here today is going to be less than production today. So that inventory will increase in that case by 20 units. Now, let's say that we were here. We produced, whatever, 50 units today. The economy was small. Well, that means in the long run, we can only consume 50 units. But today, we actually consume, whatever, 70 units. Which means this distance of 20 units is an inventory reduction. We made 50, we consumed 70. Where did the other 20 come from? We took them out of inventory. Okay. This then leads to, if inventory is changing, the warehouse is getting really full or really empty, what effect does that have on production? Well, let's assume you run a business and you have a certain level of inventory in the warehouse because you just do. Then all of a sudden, you notice that, let's say you're blue. Let's say you're in this area here, to the left of the equilibrium point. The economy is smaller than equilibrium. This predicts that inventories are going to fall. If inventories are going down, you look in the warehouse and you see all of a sudden there's almost nothing there. That means you're selling more than you're producing. Everything you produce, you're selling, plus some stuff out of inventory. What are you going to do? You're going to increase production. You're going to do that. So if your inventories are falling, you're going to increase production to try and compensate. On the other hand, let's assume we're out here, where consumption is greater than production. If inventory, let me make sure I have this correct. Let me double check this. Yeah, it's correct. I was looking at it wrong. If output is here, then you're going to be consuming more than you are, excuse me, that is backwards. Sorry. You're going to be consuming less than you're producing. This is the opposite case where the inventory is going up. So you're looking at your warehouse and you want to have this much in the warehouse and you see that it's full to the rafters. You're producing 100 units a day, but you're only selling 80. Every day you're putting more into the warehouse. How are you going to change production? You're going to reduce production. You're going to move that way. So if inventories are falling because we're consuming less than the long run equilibrium, we will increase production. If inventories are rising, and I got that backwards again. Don't worry, we'll fix it in post. This lets us look at conditions where we are not in equilibrium. Now, here is equilibrium. What happens if we are not there? Output income is higher than this equilibrium. Well, that means that in the long run, we would have to be, if I can draw it, we would have to be spending this much. But in the short run, we're not. We're only spending this much. Well, then look at this area. If we're producing that much, 100, which would also be 100 on this axis, because this curve is 45 degrees, but we're only short run, essentially, consuming this much. This means that we are producing more than we're consuming today. So we built 100 widgets, but we only bought and consumed 80. Where did the other 20 go? They go into inventory. They get stuck in a warehouse so that hopefully they can be sold in the future. So this is an inventory increase, in that example, of 20 units. We're building up inventory. And the reverse is also true. Let's say we had an output level here. I'll call that 50. Well, in the long run, that means that spending has to be 50. Consumption has to be 50. Because in the long run, spending, how much you produce, how much you eat have to be the same. But in the short run, it does not have to be true. This shows that if output is 50, that spending and broadly speaking consumption today is going to be more than that. It's going to be this much, say 60. Therefore, this distance will be an inventory reduction. If you're producing 50, you're consuming 60, where do the other 10 come from? Well, they come out of inventory. The factory produced 50. People want to buy and consume 60. You sell them the 50 that you produce today, and you take 10 out of the warehouse off the shelf. So if you are to the left of the equilibrium point, so to the right of equilibrium, inventories are building up. The warehouse is getting more full. To the left, inventories are falling. Why do we care about this? Because let's assume that you're running the factory and you like to have, a certain level of product in the warehouse, in inventory. If you look, let's say you want to have 50 units, whatever, in stock. And you look in the warehouse, and there used to be 50 there. Now there are 127 units in the warehouse. Inventory is building up. How are you going to respond? Say, well, we're making so many units a day, but we're selling fewer than that, and that's why the warehouse is full. You're going to reduce output. Conversely, if you want to have 50 units in the warehouse, and you look in the warehouse and it's almost empty, and you think, wow, we're producing this many units a day, we're selling all of them, and we're selling more on top of that, drawn from inventory, how will you respond? You'll increase production. Well, that means that if you start out With an economy larger than this equilibrium, it's going to shrink. And if you start out with an economy smaller than this equilibrium, it's going to grow. Either way, you're going to end up at that equilibrium. All right, now, this makes implications for government policy. Let's assume that you're at this equilibrium. Well, it's just like with plain old supply and demand curves. If one of the curves moves, you're going to reach a new equilibrium. Now, in the long run, that has to be true. But in the short run, it doesn't. In the short run, you can be on this other curve. Now, let's assume your planned expenditure curve, this black one, is a combination of personal consumption plus investment plus government consumption. And then for some reason, the government decides to increase its spending. Well, that's just going to shove this curve up from the black one to the red one. But that means you're going to go from this level of output in equilibrium up to this level of output in equilibrium. So increasing government spending in this model is going to increase the economy's output. It's going to make the economy bigger. Let's see for the next one. Now, here comes a question. How much bigger? Well, you can do a little math with it. It turns out that if you change, just to cut to the chase, if you change government spending by that much, output will change by that amount of government times this, 1 over 1 minus the marginal propensity to consume. The marginal propensity to consume is the slope of that curve. Slope doesn't change, but if you increase government by this much, well, it's just simple algebra. That distance, rise over run, it's going to be that slope times that difference. Oops, where did we go? It's not complicated math. But I want you to pay attention to something here. Notice in the numerator, it's 1. Everything else, I'm going to show you later a variant on this where it's not 1. So this stuff will be the same. That'll be the same. But remember that in this model, if you increase government spending by $1, you get that increase in output, and the numerator is 1. All right. Here's a nice example. If the marginal propensity to consume is 0.8, and you give someone $1, they're going to spend 80 cents of it. Then if you increase, well, an increase in government spending of $1 will, by this model, increase the size of the economy by $5. That sounds suspiciously like a free lunch. Let's see. Now, why the multiplier? This is the fiscal multiplier. An increase of spending of X creates an increase in the size of the economy of more than X. One person's income is another person's spending. So if you increase government spending by a certain amount, well, some of that money, that money has to go somewhere. It's going to end up in someone's pocket. That person is going to take that amount, multiply it by MPC, let's say 80% of it, spend that, which will go to someone else. They'll take that amount, 80% of that they'll spend. It's like the way banks create money that you learned about in Principles. Because we use fractional reserve banking, if you increase the money supply, if you increase the amount of savings by X, it's going to increase the money supply by more than X. So the punchline is that it'll end up increasing the size of the economy by more than the amount initially spent by the government. Let's see. If you increase taxes, well, that results in consumption going down by exactly that amount. You take away $100 from people, they have exactly $100 less. So that's going to reduce total output. Okay. But the effects between, which would also mean that if you cut taxes, actually this is a diagram of a C1, C2 of a tax increase. Let's assume you started here and so the economy was this big, and you cut taxes by this amount between C1 and C2. That's going to shift the PE curve up to here, and the economy would grow in that case to this new equilibrium. Cut taxes, economy gets bigger. But by what amount? Now we know that if the government increases spending by $1, output increases by 1 over 1 minus the marginal propensity to consume. But if you cut taxes, which is here, the effect is not quite the same. You cut taxes by $1, output also goes up, but not by 1 over 1 minus MPC. Output will go up from a tax cut minus MPC over 1 minus MPC. So the effect of government increasing spending by $1 is not the same as the impact of government cutting taxes $1. Increasing government spending by $1, that's, I mean, broadly speaking, it's a form of consumption done by the government. And cutting taxes by $1 increases personal consumption, but not by the same amount. The tax multiplier will be low in absolute value terms because cutting taxes going down increases output, government spending going up increases output. So that's why there's the negative sign, but ignore that. Remember that if the marginal propensity to consume was 0.8, then increasing government spending by $1 would increase the size of the economy by $5. But if you plug it in for tax cuts with the same marginal propensity to consume of 0.8, cutting taxes by $1 increases the size of the economy by not $5, only by $4. So the tax multiplier is smaller than the government spending multiplier, meaning that if you want to stimulate the economy, increasing government spending will have more bang for the buck than cutting taxes, although they both will stimulate the economy. Why is there a difference? It's a difference because it is different because if you forget that, let's skip the first step and I'll come back to it. Some more money gets into the economy, either because of a tax cut or because of additional government spending. But either way, something gets spent and it ends up in somebody's pocket. That person, in both cases, will spend, for here, 80% of it, because that's a marginal propensity to consume that we're assuming here. And whoever receives that 80% will turn around and spend it, spend 80% of that. And whoever gets that money will spend 80% of that. So downstream, all the effects are the same. Doesn't matter how the money originated. But the very first step is different. If government cuts taxes by $100, the very first step is, I have $100, I'm going to spend 80. The first effect is an increase in spending of 80 from a tax cut. But if it's an increase in government spending, the first spending that occurs is not $80, it's $100, because the government's marginal propensity to consume is not 0.8, it is 1 in this model anyway. The government is not going to save some of it. The government can choose to spend 100% of it, which is why the multiplier is a little bit bigger when the government spends than when it gives you money to spend, because you're going to save some and the government won't. This has an obvious policy implication. If you want to stimulate the economy, don't cut taxes. Make government bigger and spend more. That is a core of Keynesian economics. Now, moving on to how you get from these two curves, oh man, just the first curve we're still working on, the Keynesian cross, to the IS curve. Well, what happens now? The interest rate is not shown on this graph. This graph shows the relationship between planned expenditure and output. But what happens if the interest rate changes? Well, you were at, let's say, this equilibrium point, given a certain interest rate. We assumed the interest rate was exogenous, and therefore investment, which is a function of the interest rate, was fixed. But that is not true. The interest rate can change. So if the interest rate is at R1, a relatively low interest rate, and the interest rate goes up to R2, well, if the interest rate is higher, investment spending is going to be lower. High interest rate, people don't want to borrow money to build factories. So a higher interest rate would push this curve down, which would take you to this equilibrium, and the economy would shrink. Interest rate goes up, economy gets smaller. That's what we see here. But this diagram shows us two equilibria. If the interest rate is this, the economy will be this size. But if the interest rate is that, the economy will be that size. Well, if you plot all the interest rates against economy sizes here, you get the IS curve. These are all the relationships between interest rate and output, where that is in equilibrium. That's where the IS curve comes from. And again, you can see if the interest rate goes down, output goes up, which is predicted from that model. If the interest rate here were to go from this one, R2, make sure I have it going in the right direction. Yeah, the interest rate goes down, so we would be moving upwards. The curve goes up because R2 was lower than R1. Then the equilibrium moves from here to here, and the economy is bigger. All right, that is the IS curve, and in just a moment we'll move along to the LM curve. All right, the LM curve. This shows the relationship between interest rate and output, modeling how people want to have liquidity. How much cash do you want to hold? Supply and demand for cash. The interest rate can be thought of as the price of cash. If you put your money in the bank and get 10%, if you put your money in the bank and earn whatever amount interest, well, that is the opportunity cost of not having your money in the bank. You keep it in cash so you can use it for transactions, liquid. You're giving up the interest you could have earned. So the interest rate is, from one perspective, the price of holding cash. Well, how much cash are you going to hold? In real terms, that's the money supply. If the price level is constant, then a certain amount of cash exists. It can be used to buy a certain amount of stuff. So this, the money supply, is a vertical supply curve. The demand for cash is this blue curve. Now, if the interest rate is high, the price of holding cash is high. You're not going to want to hold cash, so you're going to hold very little. It'll be there. If the price is low, why not keep all your money in cash if the interest rate's very low? You're not losing out on much interest. So you want to hold a lot of cash. So that looks kind of like a normal demand curve, downward sloping. Put them together, and you get this. Money supply, demand for cash. If the interest rate were to rise, let's say the Fed wants to print a whole bunch of money and just throw it into the economy. Actually, I'm sorry, this is the opposite example. The Fed contracts the money supply, pulls a lot of cash out of the money supply. Then the supply curve shifts left. The equilibrium moves from here to here. The interest rate goes up. Simple supply and demand. Now, how we get from the LM curve, from the supply and demand for cash to the LM curve. All right. In both of these curves, the vertical axis is the interest rate. On the LM curve, on the horizontal, it's output. On the market for real money, it's real money balances. Okay, let's assume that the economy gets bigger. So we start just assuming, because the demand for money is a function not only of the interest rate, but also of the size of the economy. If there's a big economy, a lot of stuff to buy, you want more cash to be able to buy it. Now, let's assume that the economy is relatively small. It's a Y1. Well, people want to hold a certain amount of money. That's the supply curve. Excuse me, the demand curve. This is the supply curve. So this is going to be the equilibrium interest rate. If the supply is fixed and demand is low, the price is going to be low. If demand increases, the economy gets bigger. Well, there's more stuff to buy. I want to hold more cash. This is the equivalent of demand moving right. Here it's shown as being a vertical movement, but it's the same thing. So if demand for cash increases, but the supply is fixed, the price is going to go up. The interest rate rises. So with a given money supply, there are a series of equilibria matching the size of the economy to the interest rate. If you plot them, you get that. These are all the points where the size of the economy and the interest rate correspond to make the market for real money balances in equilibrium. So now we have both curves. So these are all the points, all the combinations of output and interest rate that make the market for liquidity for cash money balances in equilibrium. These are all the points. Combinations of output and real interest rate, where the market for investment and savings, sometimes called the goods market, are in equilibrium. Therefore, if the economy is this big, that's the equilibrium interest rate that you're going to have, because that's the only one that brings both markets into equilibrium. Woof. You're going to have questions. Email me. I'll answer as many as I can. If you sort of were able to follow all that, congratulations. We're going to take this model, now that we've seen it, and in the next chapter, show how it makes predictions for various policy choices. When we're doing that, we'll also be going over more examples of this model, so hopefully it'll take some of the rough edges off understanding how ISLM works. Okay? Thanks. See you next time.